Yeah, in fact, um, oh, I think I have started. Yeah, hello everyone. This is Shri Krishna Chitur. I'm your host for today's session, and with me is Tyler Cook from PS, who's going to introduce himself shortly. We're going to wait for a minute for the audience to join in. First of all, thank you for joining us on another episode of SolidWorks Cloud Simulation Champions. I'm really actually excited about today's session. We'll give it about 30 seconds and then get started. Right. So Tyler, I was saying that I actually used to support a simulation services business. In fact, I started it from scratch, but the intent was slightly different. It was
Hmm.
to demonstrate to the customers that the tools can actually get the job done. So it was more like services to software deployment kind of an approach.
Okay.
Yeah,
I
it's
see what
not
you're
really
saying.
meant to make profit out of it, but it worked really well because when you show the customer the confidence in being able to solve their problems, um,
Yeah.
as opposed to a demonstration, right, or a proof of concept, it's
Hmm.
goes a long way. Okay, I think we can go ahead and get started. Before we jump in, for those of you who are new to this series, this is sort of one of a kind in terms of 3D Experience Works portfolio that we've been doing this year. Basically, we bring in champions like Tyler, who are hardcore fans of SolidWorks, but who have also transformed their business by adopting cloud simulation technologies that are offered on the 3D Experience platform. So this year, this is the third one of the series. We had Cargos in May, Innovonics in June, and now we have PES. The next one is going to be done by Resemin on the mining equipment development. So, Tyler, thank you for joining us. Pretty excited to have you here today. Maybe we can start off with a quick introduction of yourself and what PES does.
Sure. Thanks for having me. PES is a multi-state licensed engineering firm. We specialize in, structural, mechanical, process, commercial, and industrial design. Really work in a ton of different sectors. We help a wider variety of clients with their code compliance, equipment design, and R&D needs. We also have a commercial construction group as well. So we got a couple of projects right now. We're doing like a baseball stadium for actually a college I played baseball at back in the day. And then also for the school that I graduated from, University of Louisiana at Lafayette. We're doing the new engineering building there. So we're kind of all over the map. I'm a mechanical engineer by degree. Been doing this for uh 12 years now, something like that, 11, 12 years. I'm licensed in Louisiana, Texas, New York. We had a job in New York, so I'm actually licensed in New York, as well as a couple other states. So our firm in total, I think we have 13 or 14 states that we're actually licensed in. So
Okay.
um,
And
but
tell us a little bit about the type of industries that you work on and type of projects that you typically take up.
Yeah, so we, being from Louisiana, we started in 2010. Louisiana is really, really tied to the oil and gas industry, so that's really where we started. And then we got into renewables, construction. There's a big food industry here as well. And then process engineering and design also. So that's kind of where we started. That's the industries we played in. And then, we'll kind of get into it a little bit on the next slide, but we got into a lot of renewables as well.
Mm.
But as far as services are offered, design, engineering, drafting, project management, we do some 3D printing. We really want to be a problem solver for our clients. That's really what the niche we want to play in, and that's where we're going as a company. So you can some of the projects we're going to talk about today are projects across that wide variety of industries. So
Right.
we'll get into that in a minute, but it's we do a bunch of fun stuff. So
Okay. Pretty excited to talk about those that are on the screen right now.
Yeah.
Maybe we can take a step back and tell us about the history of PES. How do you guys start? How you grow the business?
Yeah. So this company was founded by our founder, Clayton George. He's a PE as well, really we're 100% focused in the oil and gas industry. Clayton has a ton of experience doing basket design, pressure vessels, does some portable accommodation modules as well. A lot of stuff that's really big to in the oil and gas space. And as his company started to grow, he needed to come out with new ways of making sure everything was kind of getting done when they needed to. So you'll see there, we have a proprietary automated workflow system that we use. Helps all of our project managers stay up to date on their projects, the team understands when their deliveries are, and it really did kind of shape this company into what it is today. This company really is built on clear communication. And so if we can communicate clearly internally and we can create tools that communicate externally to our clients, we've found a lot of success in just really clear and concise communication. I started here in 2020. So in one of the worst economic years to date. I worked at Stonewall Engineering. We were another consulting firm. We were competing against PES. And in 2020, it kind of our two companies, we were both in the same situation. A lot of the oil field work dried up just like everything else. And so both companies were in an adapt or die scenario. That's a little bit dramatic, but that's the reality of where we were back then. And so our owners came together and said, okay, we're not going to compete anymore. We're going to join forces. And so both companies kind of came together. We created what we call the CAS system, the Customer Alignment and Success System. It's a system that we use to make sure that our team is always aligned with what our clients their needs actually are. And if you can determine what those are, then you can, yeah, sure, we can maximize profits, but we can get that customer to trust us and continue to come back. And it's been a really great shift in how we approach our business. And it's something that I think our clients have really come to respect in the way we do things. Just fast forward a couple years. So in 2020, we actually we really got into the renewables game because oil and gas was gone. So we did a large mobile direct lithium extract facility. We did the full design for that facility, and that really propelled us into kind of where we are today, where most companies lost money in 2020. We actually had a record year. We really did bringing on that CAS system and really kind of flipping it on its head and doing business a different way, really benefited us as a company. Well, as you continue to grow, you need to continue to get into other industries. We were doing a lot of smaller jobs, maybe not small. Some of them were quite large. The lithium facility was quite a large job, but we needed to kind of go chase some different things. We needed to kind of expand our interests, get into other industries. And so in 2022, right after adopting the platform, we became pretty much 50% oil and gas and then 50%, other industries, the civil, mining, renewable energy, and then commercial construction. And so that's kind of where I guess this story with the SO and with the Samulia platform kind of started, was in 2022. And then, one thing you'll see it on the side of the screen there, you'll see those are our core values. We want to be responsive to our client. If we can come out and we can communicate clearly to our client, like I said before, we're going to earn their respect. It doesn't necessarily mean that you always have to have the answer. If a client comes to you with an issue or they have a question about something, you don't have to have the answer in that exact moment. But let them know that you received their email or their phone call and that you're looking into it, and tell them when they can expect a response. And our clients really enjoy that about us. We do after action reviews after every job. And that's one of the things we want to know. Hey, how well did we communicate? Did we do a good job? Are you happy with what you paid for on this project? It's because if, like I said, if we can communicate, then we can maximize our profits and then maximize our efficiency and do all the things that we want to do to grow our business. Do what we say what we do. That kind of speaks for itself. You wouldn't think you would have to put that as a core value, but some firms actually have problems with that. And you know, delivering is key. Guarantee designs through entirety. We're going to be with you through whatever the life cycle of your project is. We're going to be there to support you in whatever way you need us to. And then make sure deadlines when necessary. Sometimes, you know, I talked about this. I spoke at the 3DS conference, 3D Experience conference a couple years back, and you know, it's every client that comes to us, they ask, well, I need it yesterday. You're like, well, I don't have a time machine. And that's what I said. I said, I'm at the 3D Experience conference. I don't see a time machine here. If there's not one here, there's not one that exists, right? So it's you know, we don't have a time machine. So if we can deliver things short, quickly, get the projects done for our clients in a manner that meets their expectations and meets their needs, then we're already winning. So
yeah, I mean, you have a very interesting history of how, you know, two companies kind of joined forces, expanded,
yes,
and then how well that aligns with the current vision of the company. What I'm curious to know, and so are, you know, the audience of today's session, is what changed in 2022? I mean, you have been using not only SolidWorks on the design side, but also on the simulation side. Tell us a little bit about how your business completely transformed just by adopting cloud for simulation end of the engineering services business.
yeah, sure. So adopting the cloud really allowed us to take on larger projects, right? So a lot of our business pre-2022 was, you know, if we could run it on our computers in simulation, we would do that. We had some other softwares that we would use for structural analysis, some different things. A lot of those projects, in a dollar figure perspective, were quite small, you know, less than $10,000. And we could churn through those really quick, high ROI, just boom, banging them out, you know, no issues there. And so it's pretty funny because I had some numbers pulled from our just basically our revenue distribution over the past couple years or past year. So from May of 2023 to May of 2024, 25% of our business was less than $10,000 per project.
Okay.
And if you look at the total number of projects that it took to get to that 25% and just a number of, you know, quantity of projects, it was actually 75% of the projects that we did. So 75% of the projects that we did, even over this past year, were only accounted for 25% of our revenue. So what the cloud did for us, it expanded the types of projects we would take on. So that other 75% of work were projects greater than 10K. And those are kind of the ones that we really want to target when we're using the platform. It's, you know, a lot of it comes to the project manager. Do they want to run the project on the cloud? Can they get it done with some simpler tools? It really, that's the game we kind of play here is what can we take on? What tools do we need to execute? And really what the cloud did for us is it took the size of jobs that we were doing, and we were able to increase that size of jobs. Projects that we didn't want or weren't comfortable taking on previously, we were able to take on and be able to execute with a high level of confidence.
So it's you know, lesser number of jobs, but more complex in nature from a engineering and simulation perspective, and with a higher revenue potential per job. As a result, you know, you're able to provide, you know, high value, address more challenging problems, and probably time also played a huge difference, right? Moving to cloud.
Yeah, absolutely. We need, like I said before, all of our clients are looking for the quickest solution that they can find. Sometimes price doesn't matter. Sometimes it does. And that's one thing that our sales guys, we're all salesmen. Anyone who's talking about our company, meeting with clients or whatever, anyone here can be a salesman if they want to be, right? So we need to be efficient, because if we got to get an idea on where they're at from a budgetary standpoint, and then from a timeline standpoint, we can use those two metrics to gauge what we're going to charge for the project. Right. So we needed a tool. We needed a tool in 2022 that was robust, could handle it, and we could get the project done efficiently. And it really needed to work with the tools that we already had in place. So 99% of our company uses SOLIDWORKS. That's our preferred modeling, design, drafting software. And we do a bunch of engineering in it as well. The simulation tool and I'm not knocking on the simulation tool in SOLIDWORKS. It's a very good tool, and we can get a lot done with the tool. But the projects we wanted to take on, we really needed something a little bit more robust. These projects were huge, very large structures in the marine space, and we continue to use it today. And we've expanded even what we were doing, what we originally intended to use the software for. We're using it for that still, but we've gone in a multitude of directions with it as well.
So larger and more complex projects with complex physics. And what's really impressive is, within the span of last 2 to 3 years, you mentioned in our previous conversation that the revenue has doubled for these kind of projects, because this is something that you were not comfortable taking up. And now you're not only confident, but you're also expanding in terms of the industries that you're after, and also strengthening the industries that you are currently supporting.
100%. There's in the oil and gas space, a lot of clients needed blast simulations done or drop tests done, and those are things that the blast test especially, you can't really do that in simulation. You really couldn't do it in the other tools that we were using. So like when they came to us with it, we're like, oh well, can we do that? Like I bet we can. And so it's a quick email over to the team over at 3D Experience, and they say, yeah, absolutely. And they kind of can give us a good rundown on how to set it up. And so, just being able to do that and being able to do some other things with a bigger solver has been, we've been able to increase our footprint in the oil and gas space, as well as expand into other stuff.
Okay. Yeah, very good. Very, very impressive. And congratulations to you and team being able to achieve this. I want to take a step back when we're talking about 3D Experience Works. Just out of curiosity, why did you go with 3D Experience Works from Dassault Systems when there are so many other standalone simulation tools out in the market, which are really good, by the way? I mean, they're very good at what they do. What made you and PES choose Dassault Systems, choose 3D Experience Works for the step up in your simulation journey?
Yeah, it's a really good question. I've used some of those other standalone simulation vendors in the past, and they're great. The physics is fine. There's nothing wrong there. But I've had issues in the past linking a model that our designers are using, and then you move it into the model space. Sometimes you got to export it as a step file, and then if I need to make changes, now I got to communicate with my designer. We got to make some changes, and I got to go through that whole process again, remesh, and do it's from starting from scratch every time I want to do an iteration on my analysis. And so really what I was really looking for was something that was a lot more seamless. I didn't have to go and restart and go through this whole process every time I wanted to mesh my simulation model. I wanted to be able to make design changes on the fly. And so, we needed something that worked with SOLIDWORKS, and because SOLIDWORKS was the platform we were using for the first job that we did with it. Since then, we've done some other stuff with Inventor and other softwares other than SOLIDWORKS, but it works well with those as well. So there's the real need at the time when we kicked this off was we had a project that needed to be done in a crunch, and we needed a tool that we could be efficient and nimble and get the job done with. And that's what 3D Experience, the team over there, that's what they said they could do, and they delivered. So
the big takeaway is the integration with SolidWorks that keeps your process seamless. We also have a lot of SolidWorks customers who have been using SolidWorks simulation for quite a long time, and they're
Mhm.
happy customers. They love it for its ease of use, integration, capabilities. One of the questions that we get from them, and we want you to kind of answer it, is, hey, how, does the introduction of cloud actually compete with the desktop simulation? Does it completely replace the usage of desktop simulation?
I would say no. We still use both on a daily basis. Like I said, we take our project managers, they take a good look at their project, they
Mm,
figure out what the needs are,
mm,
and they make that decision. So we still use desktop simulation.
mm,
We still use cloud simulation. It really depends on the comfort level of that PM and what he's comfortable using.
mhm,
And what, does he need to get it into the cloud and do, maybe a nonlinear analysis with nonlinear material properties.
mm,
We personally don't have that capability in the desktop app.
mm,
So if we do need to get into that realm and we need to look at some things for plastic deformation and plastic stress, strain, et cetera, then we
mm.
need to bring it into the cloud. It really is project dependent, and we still use both. And I don't know that there'll ever be a situation where we don't use both. We have
Okay.
some really good examples of core projects that we do, and that's the simulation app. And I can plug and play that into anyone who starts at our company, and they go with that. Now, if we need to go into the cloud solver, there's going to be a little bit of extra training going on, right? It's
Of
it's it's
course.
more robust. There's
Yeah.
more things you can do,
Mm,
and it takes some training. But
right.
in terms of how quick of a turnaround it is to understand what's going on from the way you set something up in the desktop app to setting it up on the cloud, is really seamless. You just got to
Mm,
figure out where the buttons are. Is
right.
is 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 the main problem with most softwares, actually.
I'm gonna use
So
that as my email signature. Just got to figure
yeah,
out where the buttons are.
just got to figure it out, man. That's the main struggle we face.
So you brought up an interesting point. And correct me if I'm wrong. Is it fair to say that uh, SolidWorks simulation on the desktop and the simulation applications on the platform are quite complementary to each other? And if I may relate it to your kind of projects, is it fair to say for some of the simple linear static jobs, you still use SolidWorks simulation, and for more complex applications involving larger geometries, complex scenarios, a lot of contacts, you would prefer going with the cloud?
100%. That's very accurate. If, we do some downhole tools here, right? So if I'm going to do an FEA, an analysis on a single component of that
Mm,
downhole tool,
mm,
downhole tools could have, hundreds of components inside of them, right?
mm,
It could get very complex very quickly. So maybe I'm doing, pressure, tension, that kind of analysis on a single component, right? And I can rate that component pretty quickly. I can get the design honed out. But if I need to understand the interaction, maybe I had one recently where I had two parts that were rotating, and there was, I guess you could say, some large displacements were necessary. So we had to rotate it
mm,
and make contact, and had to come into contact and do a bunch of different things, right? If I'd have tried to run that on my desktop, the simulation solver probably would have had some issues with it.
mm,
Moving it into the cloud and running it on the 3D Experience, the structural scenario platform, I didn't have any problems. And we'll get into some of the other features later, but there's a lot of features in it that I like that make my life easier. So I'll wait until then. But it's
okay.
that more robust solver can really help you whenever you have a complex assembly.
Okay, okay, makes sense. I see a couple of the audience raising their hand up. I just wanted to point out to you guys that you can type your questions in the Q&A using the Q&A button in the chat window, or you could use the chat window itself, and we will try to address those questions at the end. If we're not able to address them, we will have your emails and come back to you. Going back to our discussion with Tyler, another very common question that comes up is, hey, what's the typical ROI when you invest in these tools? And I remember you mentioning during one of our previous panel discussions that, with PES, you got your ROI just within one project. Um, can you elaborate a little bit on how that happened, and you know, and your
Yeah.
learning curve as well?
Yeah, for sure. So I am the COO here as well, so I have to make all the financial decisions. From an operations standpoint, is do we need to get more software? And at the time, well, really now, still to this day, I don't like to buy new software unless I have a project that's actually going to pay for it. So we had a project that came along, one that we would have turned down had we not had the solver, the 3D Experience solver. And I looked at the price of the software. It was very competitively priced with some other vendors that we talked to. The real selling point was it merged directly with SOLIDWORKS, and I wasn't going to have to deal with a bunch of the problems I've had with, transferring files between softwares before. And so on that first job, it was quite a large job. This project, it paid for itself on the first one. And then we had several projects that came through after we completed that job with multitude of clients that we used a solver. So the ROI was within first month, it paid for itself.
Wow, that's awesome.
So yeah.
And how long was your learning curve, being introduced to a new application?
It probably took us probably took me 2 to 3 weeks to kind of get everything kind of figured out. The job needed to be completed in about 6 weeks. Okay. So it took some time to understand. We worked with a gentleman named Ramesh. He works for 3D Experience, and he's a great guy to work with. He's very good at explaining things and working with us and getting us how to work it. So after that kind of job, like I said, it was a very large structure, and we had to figure out a lot really quickly. And so that we learned so many things on that first job. I still reach out to Ramesh when I have something weird come up. But for the most part, the learning curve, I'd probably say 2 to 3 weeks. We were off and running and ready to go. So,
but that's on the first job. I think as you picked up second, third, and fourth job.
Yeah, oh yeah, it got much quicker. Much quicker. Yeah.
Right.
Yeah. And that first project got out on time. So we met our delivery, got a good product out there, and we're happy with it.
And also
happy with the software since.
Right. Yeah, good to hear that. And since you brought up Ramesh, for those of you who don't know, Ramesh is a simulation rock star who also happens to be the co-producer of this show. Today, he's traveling. Unfortunately, he couldn't join us. And so does my co-host, Ronit, who could not join us because they're both traveling, meeting customers as we speak. Okay, moving on. Another very important question that we get from our SolidWorks, hardcore SolidWorks fans is, hey, SolidWorks has PDM, which is product data management, which they're very comfortable with. They love it. And now platform introduces the concept of PLM. The most common question that we get is, how do you deal with managing data both on SolidWorks and on platform? How different is PDM versus PLM? And, do you run into disruption in your workflows because you've now introduced the product lifecycle management based environment to a product data management based environment?
Yeah, so I've been using PDM. One of my first jobs out of school, we had PDM, and I love PDM because it saved me several times on projects. Checking in and checking out, that's where it's at. You can go back to old stuff and use it. I love the PDM product. When we brought on the platform, it has a similar, like you mentioned, it has a similar system. We really use PDM as our file management, and the use of the PLM on the platform does not in any way cause any issues on our design workflow process. I use the PLM feature, whenever I'm doing some engineering cycles, as I'll use it a little bit there. But really, I prefer to keep all of our data in the PDM system because that's what our designers have direct access to. And I can give my designers direct access to the PLM. It's just we really only have 1 to 2 seats per year, depending on how busy of a year it is in the platform. So we keep everything in PDM. That's where we house everything, our drawings, PDFs, everything, client documents, everything goes into PDM. And so we use the platform, but really only on the analysis side whenever
Right. Right.
I'm going through design cycles there. But
Yeah.
the
And
live
also,
files that make everything are impeding.
right. And also when it comes to simulation data, it's not like CAD where you have to maintain configurations and revisions.
Right.
At the end of the day, from a services standpoint, all you care about is the final simulation model, you know, where you've done all of your analysis and you're confident of the results. And that's pretty much the data you're going to keep,
Yep.
and not the whole set of revisions that it took you to
Correct.
get to this final stage, right? In fact, we've seen some customers who don't even keep even the final simulation model. They just keep the report of all the results, and that's good enough, right? So I
Yep.
guess in your case, PDM is still your workhorse in terms of data management, but you leverage the PLM aspect mainly for simulation part of the work.
That's very accurate. Yes, sir. That's kind
Okay.
of our work.
All right. And that brings us to the perfect transition point to talk about some of the simulation projects that you've done, and talk about the challenges, how they were overcome, and so on. So the workhorse in your case is the structural performance engineer role that leverages the abacus based technology for linear, nonlinear, and dynamics applications. um, Tell us a little bit about what you like the most about structural performance engineer role.
Yeah. So we don't do a ton of dynamic analysis here. So we do a lot more static structural load cases. Buckling comes up quite often.
Hmm.
It we're going to talk about a project we did use the mechanical,
Mhm.
but really there's so many options that are available to you in the structural performance engineer that on what we're doing today currently in our business, we really don't need anything else because you can do everything that we do is listed there and it's part of the package. The nonlinear solver is great. I really enjoy using it. The nonlinear materials and everything you're able to do, it just all comes in this package, and it's been working well for us over the past couple of years.
Yeah, and I guess you always mention how robust the abacus solver is for some of
Mhm.
the crazy simulation applications involving complex physics and geometries.
Yeah. Yeah, I mean that's what I tell my guys all the time. They'll come to me and say, "Hey, can it do it?" And I'm like, "Yeah, it probably can." I mean, it's there's a good chance that we can do it.
Right.
And then if we do need to buy up and get, one of the higher tiers of the program, we can do that and it gets implemented very quickly. And
That's a good point.
we get to stay dynamic in how we operate. So,
Right. So it's the flexibility offered by the cloud licensing
yep,
module. Okay, makes
yep.
sense. Okay, let's dive straight into one of the projects that you guys worked on. So tell us a little bit about, the project, the challenges, um, and then we go from there to, how it was executed.
Yeah, now actually I'll share my screen and kind of share
Sure.
what the model of this thing looks like, because you kind of just by that picture there I'd be explaining and the audience would be a little blind. So
Sure.
let me
Go ahead.
share this. Can you see the trailer on my screen?
Yes, I
Yeah, there
do.
we go. Okay, great. Okay, awesome. So this is a trailer that our client sent to us, and what actually sits in this trailer, there's a large tank that sits in the saddle structure. And that tank has a gaseous material in it that could be toxic or harmful to the environment. And then in this back area, there's actually a control console. So if you're designing a trailer and something's going to be on the road, it's not a matter of if it will get hit by something, it's a matter of when, right? And so
Mm-hmm.
the client's main concern with this project is if my trailer gets hit, one, we need to design it to, whatever the relevant structural standard is. And there's several, it's called CFR, Code of Federal Regulations, that outlines how you design a trailer, okay? And how you design that trailer for rear impacts. Well, what our client was really, really concerned with is, yeah, we did a structural analysis, we got the structure designed to code, But if there is an impact that occurs,
Mm.
will the tank be clear of anything that might break, or will the car go and hit that tank directly? If it were, like, what's going to happen to our structure if it is impacted? And so, like I said, control console, they're not worried about. But if anything were to penetrate the tank that sits right here, there could be, some big issues. And so what we did is we had to do a ton of research. We had to find some sort of standard that kind of outlined, hey, how do you design a trailer for a dynamic impact study? Right. And so we did a lot of that research, found something that we could kind of say, okay, this is actually how they design them. It's a standard that we can lean on and make sure that we're doing this with some sort of industry standard that's out there that is respected, right? And so what the client really wanted to know is they wanted to know how far this bumper would, or this rear beam would penetrate into the structure if it were hit by a vehicle. Okay. And so this is, we can go, I'll stop sharing my screen now. And we can go
So the
back.
downside is, if there is a pretty significant impact, that could lead to the rupture of the tank, releasing toxic material into the
That's correct.
atmosphere, right? Wow, that's
That's correct.
scary.
Yeah.
So
Yeah, it's it can, a lot of times what we're doing can be a bit risky. So we want to, again, that's another reason you want to have a good solver that you can kind of trust and lean on and make sure it's got the physics right.
Right.
So the trailer impact, it happens at, you actually see it in the image on the screen now. It gets hit in the corner, and that's one of the load combinations you have to do. And it deflected, I want to say this one deflected somewhere around 10 inches in the middle. Client wanted it to be less than a foot. So that's the design that we put in front of them actually maintained what they were trying to get to. So they felt confident. The trailer actually starts, or the vehicle, the big block that's in the back, it's traveling at 35 miles an hour when it hits the trailer.
Oh, wow.
So yeah, so it's moving pretty quick. It's not flying 100 miles an hour. I don't think anything out there would survive, right? But so that was
also,
kind of
I'm
what
seeing that in the simulation result, the timestamp on this is like 0.04 seconds at the end.
Yeah, it's quick.
It's like such a quick, high force impact. And there's a lot going on from physics standpoint, right? You have very complex contacts, parts that are actually touching themselves because of the contact, and a very high deformation that it's experiencing. So is the end goal kind of to ensure that the deformation that the trailer experiences is within the acceptable safe limit in preventing any rupture of the cylinder?
That's correct.
Okay.
And yeah, so some of the assumptions in this, it's the trailer is, I'm not allowing it to move in what's actually the X direction or the longitudinal direction. If it is hit, it is going to move a little bit. So this really is worst case scenario. For whatever reason, that trailer it's stuck, it's not moving, and it gets hit by a infinitely rigid body. And what's the worst case deflection or deformation that we're going to see? And it fell within what they wanted it to. So they were happy with it. We were happy with it.
All right. Also, it's a really cool simulations. We engineers like to see things break, crash.
Yeah. Yeah, we do.
All right. Tell us a little bit about how this impacted client and PS as an organization.
Yeah, so the client was actually a bit behind on this. They needed to get this project done pretty quickly. Definitely the structural analysis side of it, other than what we did here. This was an adder for them. I said, we can do it if you'd like to see it. They said absolutely. So we got to add a little bit on our quote to do this analysis. But they really needed to get this trailer registered by Department of Transportation in the area that they're in. They were up in Michigan, I believe. And so they needed to get it through DOT approval, and so that they could get it on the road and start mass producing these trailers to go. And they were pretty far behind. And so we were able to help them accomplish that goal. And then for us, we acquired a new client that They're really happy with the work we did. So we do expect to have some recurring business with them. It's about time I make a follow-up phone call. So that's kind of, we're always trying to add to our business, get new people, get new clients, new industries. This was definitely one that was a new industry and a new client for us. So we're really happy with it.
All right. I mean, that's a huge, business impact, right? And being able
Mhm.
to deliver these kind of projects, which you couldn't in the past, has probably
Right.
added a lot more customers with a similar situation to PES.
Yes, sir.
All right.
Definitely.
Let's move on, talk about another very interesting project that you've worked on, which is the 30,000 pound mass scissor lift. Maybe if you have a image or a video just for us to understand the scale of this thing.
Yeah, so just dimensionally, I got a video that I can show in a
Sure.
second,
Yeah,
but
go ahead.
it's 20 feet long
Mhm.
and it is about 9 foot wide, and then it'll get up to 10 foot tall.
Wow.
And so what is a very, very, very expensive piece of equipment.
Mhm.
Um, it performs a very serious role for this client's application. And what was happening was they were seeing some fractures down here, down at the base near where those links are shown. They're actually cylinders. So let me share my screen and you guys get a little bit better view
All right.
of what it does. Do this one. So, all
Yeah.
right, you should be
Yes.
able to see. So you see this area where our client has, and they have actually welded on some plates. They
Mm.
were seeing some from fracturing right here, didn't really know what it was causing it. And so what they needed us to do is perform a structural analysis for them to see if there were any, significant stress risers in this area.
Mm.
And so this is kind of a zoomed out version, but let me show you the video of this system operating. So it actually sits underneath the floor, and it picks up this transfer system is really what it does. It takes a big tray off of this structure here, and that tray gets onto here, and then it's an assembly line, so it moves it to another area. But the scissor lift, these cylinders extend, pushing up the table to go and grab these trays. This is kind of what it does,
Mm.
and it's pretty massive. Like I said,
It's
the
pretty huge.
total weight of everything, the tray and this system on top of the table, the scissor lift itself, inclusive of the weight of the scissor lift, weighs about 30,000 pounds.
Wow.
So it's very heavy, very serious piece of equipment that, let me pause this. I think we're about to start walking around the shop. But that's what it does, is how it operates. And it's a very key piece of equipment, and they were having issues getting with the original manufacturer of
Mm.
this piece of equipment to try to figure out kind of what was going on. So the solution we provided was we came in, we reviewed the hydraulics, we reviewed the structure, ran some analysis on the structure, got an idea of where those stress risers were kind of coming from.
Mm.
And I think a lot of this actually had to do, this is actually the final structure, so you don't see nearly as much stress built up in
Okay.
it as before. But we did have to add some structure to where the cylinders tie in. They were getting beat up pretty bad.
Mm.
Each one of those cylinders will put out about 37,000 pounds of force
Wow.
to raise and lower this system. So we added some structure there, and then we added some other things in some other areas just to kind of it really is a fatigue issue. This plant runs 24 hours a day,
Damn.
almost
Yes.
365 days a year. So it sees a lot of fatigue. So anything we could do to relieve some of the stresses in those areas where the failures were occurring was what we were doing.
I can imagine you know, cloud would probably help big time in cases like this, just in terms of the turnaround time for these kind of projects, because it's not that you set up a simulation, you run and you're done, right? It's an
Right.
iterative approach where you're trying to figure out the right setup, right materials, and getting the right
Mm-hmm.
results. Um,
Yeah.
is it
Yeah. And
fair to
so
say that cloud was helpful in cases like this?
Absolutely, because we had to go through. We also had to as-built this. We didn't have any drawings of this system, so we had to go out and
Mm.
measure everything, build it from
Oh,
scratch in SolidWorks, and then run the analysis. You
okay.
know, and so it was quite a task. It was a really nice size project for a client that had been dormant for us. And then there's several configurations we had to run it in. So
Mm.
it starts low, it goes higher, and so it has some other dynamics that kind of go on with it. And what we found is in this position that it's actually shown on the screen right now, when it's lower, that's when the stresses are actually the highest
Mm.
because it does not have the mechanical advantage as it does, as it gains, as it starts to
Indeed.
rise.
Right.
And so we're seeing a lot of bending in that angle member that's shown at the bottom.
All right. Very cool.
So,
Tell us a little bit about the benefits that the client received and the values that PES realized at the end of this project.
yeah. Yeah, so they had been actually repairing this structure several times and replacing the cylinders, and downtime in this shop is not good. You know, the products that they are producing they sell them almost as soon as they're done manufacturing them, they're out the door.
Mm.
It is an oil field application. I won't go into really what they do, but you know, this structure being down is a big problem for this facility. And
Mm.
so it started out, hey, let's assess the structure. Let's see what's going on. Maybe we can make some temporary modifications to help us get through until our next turnaround.
Mm.
Well, what ended up happening is they had some issues. It's a bigger company. It's harder to get people on your vendor list.
Mm.
So what ended up happening is we have fab shops that we work with daily. They send us work. We send them work. We manage some of the construction jobs. So this ended up turning from a dormant client that we hadn't done work with in several years. We had lost all our contacts there, needed to get back in the door. We were able to do that. We were able to give them the confidence that we can do good engineering work. And we mentioned to him and said, hey, if you need us to build one of these for you, we have
Mm.
some fabricators we work with that we can. And so currently, actually, I got the revised quote back today. So I think potentially this week we're sending our quote out to this client. And we have a potential that we're going to project manage the build
Oh,
on this piece
wow.
of equipment and then manage the installation as well. So it turned into this client we haven't done work with in forever. We
Mm.
turned that into this really great opportunity where not only do we get to showcase our engineering ability, but we get to build something that we designed, which is always something that we strive to do. We always want to be, you know, we want to be through the guarantee designs through entirety. We want to be as involved in the project as much as we can be.
That's awesome. And right now, is this in the fabrication phase?
It will be. We're still quoting it.
Okay.
We had some issues finding a good cylinder vendor. We end up finding the one that they used.
Mm.
It takes a while. This is a large piece of equipment, very expensive. So
Sure.
it a lot of things, a lot of T's that need to get crossed and a lot of I's that need to get dotted before we send it out. So we'll be sending that out this week, and hopefully we'll get a PO on it and we'll get started building pretty soon.
Okay, I'm sure you will.
Yeah, I
Uh,
think so.
all right. Moving on, let's talk about um, sort of the last example
Yeah.
project that you worked on, which is another 30,000 pound mass A-frame.
Yeah.
Tell us a little bit
So
about this one.
yeah, so 30,000 pound mass is actually the load that this system is rated to pick up.
Okay.
The entirety of the entire weight of this system is around 60,000 pounds, and then you add that 30,000 pound load on it. So now you're actually at 90. So it's rated to pick up 30,000 pounds. Just general dimensions of this thing are it's 52 feet,
Mm.
7 inches tall.
Mm.
And then it is approximately 42 feet wide. So
Wow.
it's a very, very large structure picking up a very heavy object.
Yeah.
And and we had some very interesting, this had to be done to ABS standard. The client wanted some extra load cases ran. He wanted to know what would happen if a single cylinder were pulling on it, or hydraulics went down on one of the cylinders, and he wanted to make sure structure was safe under that loading scenario.
Mm.
And so you get a lot of big deformations. Again, it's a very complex piece of equipment to mesh. Has to be ran in several configurations. So the solver as a whole gives us the ability to, it's called an assembly of meshes, and we're going to talk about it a little bit more later. But I can mesh this system once and run it in each one of those configurations, and I don't have to go back and remesh it. That's a huge advantage for us. This is a very complex. I know it doesn't probably look complex from the outside, but there's a lot of structure going on the inside of those legs, that we had to mesh, and we had to make sure it was contacting correctly. And it was quite an undertaking. It was a big job, needed to get done quickly. They've installed it, and they'll be load testing soon. So it's a pretty big one. It's massive. I've stood next to it a couple times, and the images you see here don't really do it justice. It's pretty crazy.
Just out of curiosity, how long do these simulations take to run on cloud?
The ones with 2 cylinders or anywhere can run anywhere from an hour to 2 hours. When I have the single cylinder load cases, sometimes those would get over 3 to 4 hours. Like I said, it's a massive structure. Excuse me. I have a really fine mesh on it. It has some really interesting spots where kind of the stress will start to develop. And so it took a lot of mesh refinement and kind of doing some different things in Abacus that I definitely, from a meshing standpoint, would not have wanted to do for all the configurations that we had to run and all the different films. You can duplicate films, you can do a bunch of different things, and it just makes the platform really does make your life easier when it comes to that meshing and meshing controls and doing all that. So
and 3 to 4 hours is amazing for a
yeah,
simulation of this size.
Yeah, it's huge. And I forgot what my nominal mesh size was, but just for reference, that the crossbar going across, that is I believe that's a 42-inch OD pipe. Wow. So it's a 42-inch OD pipe, and I want to say I put a 1-inch mesh going in with 3 elements through the cross section, I think is what I did. But there are other areas on that system that are meshed significantly smaller because we have some stress concentrations in certain areas. We have some wells we have to look at very specifically. Kind of where the crossbar meets the legs, there's a weld that sits under there that is a concern point. And so it's a big structure, and it's impressive. It's massive. And like I said, without the solver, we probably would have had to turn down this project, because I don't know that we could have got it done in any of the other softwares that we use, or if we could have, I don't know if I would have trusted them as much as I trust the solver.
Right. So that's good to hear. Tell us about the impact of this project on client and on your organization.
Yeah, so we did the full design on this. There was no as-built. Client kind of had a similar project before. They shared some stuff with us, but we had to go through. We spec'd out all the shibs. We spec'd out the fair lead. That's in the middle right there. It's a very complex, not extremely complex, but the way the wire rope. So there's a wire rope that wraps around this thing so that you can pick up the object, and large cylinders. Had to go and spec out those cylinders. Sent the client. We had some certain extensions that it had to get to. It had to go outboard so many feet, so many what different angles. So we had to go through and figure out, make sure that the cylinders could get there. Check all the loading on the cylinders. You have issues with cylinders buckling. So there was a ton of different design aspects that we had to take into account during the design work on this thing. And then again, like I said, inside of those legs, there's a lot of structure in there. So drafting, had to do all the drawings, fabrication drawings on it. And for the client, they needed that done quickly, of course. And it kind of continued to open up doors for us in that industry. This is a marine industry project. So we got to work with a boat manufacturer, or the people modifying the boat or the ship, however you want to call it, that this is going on. And it led to another project, and it's been we've constantly been able to expand our business using this
So now
model.
you've added another realm of expertise
Yep.
as the service, allowing you to penetrate a different industry. That's impressive.
Yep. Yes, sir.
Okay, we are almost near the edge of the hour. Let's quickly talk about your top 3 favorite capabilities in 3D experience.
Yeah, so high performance computing on the cloud. As I said before, I'm our operations manager here. I have to look and make, the decisions from a financial standpoint. And so, when we decided to purchase the software, we really didn't have computers, and we kind of still don't today, that could run these, simulations. And so I have to weigh the cost of, say, okay, if I go with someone else that I don't have cloud computing opportunity with, I may have to upgrade all of my machinery. I may have to buy another server to run these load cases on. There's a lot of, then I got to get my IT company to come in and do all that install, and that costs money, and the dollars start racking up, right?
Right. And
This
also, it's
was
not a one-time deal, right? You
no,
have to keep
and then it
maintaining the equipment.
continue. I have to maintain it. I have to, as the software upgrades, I got to do upgrades on my server, and it just becomes a long, drawn out process through the life cycle of running this business.
Right.
What this cloud computing did for us is I made a phone call. I had to write a check, right? Again, very well priced, I thought at the time, especially for the project that we were taking on with it. And we got it implemented within a couple days, got our logins, got straight into running and working through, the issues on the solver. I didn't have to buy anything. I didn't have to wait for components to come in. I didn't have to wait to schedule something with my IT department. I buy it. They do updates on their side. Dassault and whoever their vendor is for their third party computing, they work through all those upgrades on their end. I don't have the headache of having to do that. I just need to open the software, make sure it's up to date, and I'm off and running. So getting the accessibility and getting it implemented and getting to work as soon as possible was a huge selling point for me. And then the next one I'll go into is this automated model building. Assembly of meshes. Like I said, a lot of the structures that we're doing, they're going to have several configurations these are moving structures. We're going to have to run several configurations. I don't want to remesh that model every time I do that. So the way that works is with the PLM file management feature is I can open up a component. If I want a single component in the assembly, if I need to make a design change, I can make that design change, push that design back to the cloud. My mesh that I had before is still there. Okay. Now you will have to do a little bit of cleanup if you combine some parts or you do something funky in SolidWorks. You have to come in, you have to clean up your mesh. But generally, if I just change the thickness of a plate, if that's something that I want to do, then I just bring it back into the solver. I press update. My mesh updates automatically. My contacts are still there. Everything is still there that I've worked through up to that point. And I'm ready to go back to running very quickly. Okay. And so the assembly of meshes, if I have a component that is in one, with that A-frame, it had several different angles of deployment, I'll call it. We got an inboard load case, an outboard load case that where we're picking up a very heavy mass. And then I have an even further outboard load case where I'm almost horizontal with the deck of the ship, where I'm picking up a very small boat. Okay. For those 3 positions, I didn't have to remesh that every time. It was already meshed. I brought in all the models stayed the same. I just, boom, opened up the configuration. It's a configuration in SolidWorks, but there's another name for it. You have to save it as not a config. It's a
revision.
I forgot what it's called, but the config is saved as a product model or something like that. And you bring it in and its mesh is already there. I just got to go through and update my FIM and I'm ready to go. So there are some things you have to update between those configurations, but as long as you manage your files appropriately, all that data stays there. You don't have to redo it.
Right.
And
it's literally a digital
deal.
twin approach, right? Where
100%.
whatever you want to simulate without having to recreating the same simulation models. I mean, imagine if you were to do this in a standalone simulation tool, no matter how good that is, you would have to import from SolidWorks every single time, and as a simulation user, it's the model build that takes majority of your simulation time, right? So
Yeah.
avoiding the repetitive, unproductive tasks, I think that's a big value. Okay, let's talk about the last one.
Yep. And then results visualization. So the way that the solver works is you can start a simulation and you can tell it the step size you want it to take. I always like to start my first step at 10%. Because if I'm running, especially if I'm running a linear analysis, I can actually visualize those results while the solver is still going. I can look at like the 10% solve step, and then I can assess if my model is actually running correctly. You know, sometimes every now and then you'll get like a bonded constraint that shouldn't be there or something. And so you see this, you know, this spot will highlight red or whatever. And, you know, I got to go make, oh, shoot, I got to stop this. And I got to go make a change to my setup. My setup was wrong, right? You can do that while it's running. You can visualize those results. You can assess to make sure that one, you got the physics, you have your FIM set up properly. And then two, if it is, and then you can stop it and go make a change. You don't have to wait for it to get to the end. I don't have to wait 3 hours for it to finish. I got my first, you know, load step in 30 minutes. I go and I look at those results. I can interpolate them up.
Right.
I can assess if it's set up properly. And then two, if I see a design change that I need to make, I can go back into SOLIDWORKS. I can make those changes, you know, come back. Maybe there's a 25% solve step I want to look at, review those results. Okay, yeah, it's still going the way that I thought it was going to go. I can stop my solver, import from SOLIDWORKS those design changes that I implemented after reviewing that 10% solve,
update
and update. And then boom, I'm back running again. Okay. Right. So I played baseball for a coach. He said work is one of his famous lines was like, work while you wait. Right.
Yes.
And so I don't ever just want to be sitting on my hands, not getting something done. Sure. Oftentimes I have other projects I can go work on while something's solving, but if I'm in a time crunch and my client's in a time crunch, I really want to know where those results are going to be as soon as possible so that I can make the design changes and keep moving forward. And that's one of the huge benefits that are one of my favorite features in the software.
All right. All three are, you know, probably my top three or within my top five too. Makes absolute sense.
Yep.
Okay, we are already 2 minutes over time, but I just want to take 30 seconds of your time to quickly tell us about the future at PES.
Yeah. So what's interesting is when we made these slides, we didn't have a CFD project. I've got 2 CFD projects going on right now. So we're getting into more fluid simulations.
Nice.
We're always looking to expand into other industries. We want to be as diverse as we can be. And then we want to expand into other projects in our current industry that we've talked about that quite frequently throughout this webinar. But in terms of globally where we want to go, we've got about 15 employees here now. We want to get up to 30. Whenever we get up to 30 employees, we can kind of start talking about maybe sectioning out some divisions. With those increased double our team size, we're also expecting to increase our revenue by at least 2 times. And so when we do that, we can continue to grow. We can maybe get some different divisions, start really focusing, you know, certain people whose skill sets are really good at certain things. Let them focus on what they're good at. Let them keep expanding their client list and what they do. That's really what the CAS system is about. It's about bringing in people who maybe have this entrepreneurial spirit, right? Not maybe, they have that entrepreneurial spirit. They want to be an entrepreneur. They want to start their own engineering firm or design firm, but they don't want to deal with the overhead, right? So that's really what our system does for the people who really buy into it and take off. You're going to come in, it's going to be like running your own business. You're going to get that opportunity. And what we're going to do is we're going to allow you to focus on what you like to do. And we're going to take away the things that most engineers are not good at, and that's dealing with people. And so we're going to take all that away, all that burden of the overhead and everything else that comes with it. We're going to take that up. We're going to deal with that on my side and with my management team. And so that's the people we're looking for, are entrepreneurs who want to grow. And that's really where we're at.
That's a very appealing pitch to anybody who's interested in working in PES. I'm sure you're going to get a lot of resumes in your inbox after this
I hope
webinar.
so. I hope
Well,
so. That'd be awesome.
all right, we are at the end of the hour. It's been an absolute pleasure having you on this series, Tyler. Thank you for sharing all those valuable insights and the journey of PES. Congratulations on transforming your business. And again, we thank you for your time. And I hope you enjoyed this conversation as well.
Yep. Thank you. Thanks
All
for
right.
having me.
Yeah, no problem. And thanks to all of our audience for joining us again today. And the next one, we will have our friends from Resemin talking about doubling the throughput for mining product development. Till then, we'll see you guys. And thanks again. Have a good rest of your day or evening. See you.
Thank you.